Hello my dear students. So today we study about identifying rational and irrational numbers. So before we have to move there, we just know about division rule. So we already studied this one. So dividend, divisor, quotient, and this is remainder. So this is called the quotient, and now we have to identify the rational and irrational numbers on the basis of quotient. Note it please. Identifying the rational number and irrational number on the basis of the quotient of decimal expansion. Quotient decimal expansion. Okay. So for this I will solve one example here. Suppose 1 is the dividend and 2 is the divisor. Here 1 is less than 2. That's why if you would like to make it 10, then automatically here is the decimal point. Then 2 5's it is 10. The remainder is 0. Here 0.5, this is the quotient. So this is the decimal expansion, and on the basis of this expansion we have to identify whether the given number is rational number or irrational number. So to study this one, we have to know about the 4 terms, the meaning of 4 terms here. The first one, terminating. The first one, terminating. So what is the meaning of terminating? So terminating means decimal expansion stops or ends. Decimal expansion stop or end. Okay. So how it is here, check it out. Already we solved here example 0.5. Okay, this is the quotient and this is the decimal expansion. Here after decimal point 5 is only one digit, so it stops. If the decimal expansion is stopped, then it is called the terminating. Okay. So next one, second, non-terminating. Non-terminating, it means if the term decimal expansion will not stop or it will not end, it means non-stop. Okay, non-stop. Decimal expansion will not stop here. Decimal expansion is continuation. For example, here 0.725691 dash dash dash. This is the continuation. If decimal expansion will not stops, then this is called non-terminating. Non-terminating. Okay. Third one, recurring. Recurring means it is the repeating. Recurring means it is the repeating. Repeat. Okay, repeats. How it is? Example here 0.727272. Okay, here check it out, 727272. This is the repeating. So this decimal expansion is called recurring. If the digits are repeats, then it is called recurring. Okay. Next, fourth one, non-recurring. Non-recurring means decimal expansion will not repeat. Decimal expansion will not repeat. It means no repeat at all. No repeat. For example, here 0.31465 like this. So here terms will not repeat. So this is called non-recurring. Okay, here the first one, terminating means decimal expansion ends or stops. Non-terminating means decimal expansion will not stop. Recurring means decimal expansion repeats. Non-recurring means decimal expansion will not repeat. Okay, I think you understand the meaning of terms. Now, making these terms combination, we have to know whether the given number is rational or irrational. Okay, the combination of these four terms. Okay, now move towards the next one.
Now we discuss about the combination of the terms, whatever we discussed. Here on the basis of quotient, after seeing the decimal expansion, we clarify that whether the expansion is having terminating recurring, first one, or terminating non-recurring, or non-terminating with recurring, and last one non-terminating and non-recurring. Here, if the decimal expansion is like 0.4343 like this, then automatically this type of expansion, decimal expansions, are called as terminating recurring. Why it's called terminating? Because the digits are ending here. 0.4343 decimals end here, so it's called terminating. Why it's recurring? Because digits are repeating here, 4343. These are the digits repeating here. That's why this decimal expansion is called that terminating recurring, terminating with recurring. And here for second example, terminating with non-recurring. So here 0.875. These are the examples I am taking here. 0.875. Here once again terminating. Why terminating? Because decimals are ending. Decimals are ending. So here first one 8, second one 7, and third one 5. Here all the digits are different. It means they are not repeating. That's why it's called non-recurring and also terminating. So this is the decimal expansion, for example of terminating with non-recurring. And third, non-terminating with recurring. For example here 1.3333 like this. This is non-terminating because decimal expansion is continuing and also the digit is repeating, that is 3333 digit repeating. That's why this type of decimal expansions are called non-terminating recurring, non-terminating recurring decimal expansions. Okay, and the last one, non-terminating with non-recurring. It means the decimal expansion never be stops and not be repeated. Okay, so here for example I am taking here value of pi, that is 22 divided by 7. It becomes 3.1416 dash dash like this. Okay, 3.1416 dash dash. Here this is non-terminating because decimals will not end here. It becomes continue as it is. Non-recurring means the terms or digits are not repeating here. That's why this type of decimal expansions are called non-terminating with non-recurring. Okay, so here examples, root 2 value is 1.1 1 4 maybe something, just wait. One point 4 1 4 2 1 3 5 6 dash dash dash. Let's continue. Here once again this decimal expansion is also non-terminating and non-recurring because it is not ending and not repeating. Okay, so when the decimal is not ending and not repeating, that type of numbers are called irrational numbers. That type of numbers are called irrational numbers. Otherwise, the above three are called, this is decimal expansion for the rational number. This is for rational number. If the decimal expansion is terminating with recurring, then it is a rational number. If the decimal expansion is terminating with non-recurring, then also it is a rational number. If the decimal expansion is non-terminating with recurring, then also it is rational number. If the decimal expansion is non-terminating with non-recurring, then that type of decimal expansion having the numbers are called irrational numbers. Here pi is one example, and root 2, root 3, root 5, they are all examples for irrational numbers. Why? Because the decimal expansion having their non-terminating with non-recurring. Okay, thank you.